Hello everyone, how are you all doing today? In this video, we'll master every single integral formula that exists out there in extreme detail. So after watching this video, you will never have to look at any other video or resource to look for integral formulas. I'll also make sure the PDF of this formula sheet that we are doing in this video is available in the description. So make sure you check out the description after watching this video. We'll start by learning algebraic functions and then we'll move to exponential functions. Then we'll be moving to trigonometric functions and then we'll also look at some special integral results that we should know in order to solve integral problems. Now let's get started with the algebraic functions. So when I say algebraic is nothing but whenever there is a variable to the power constant, such a pattern is called as algebraic. So for example, x to the power n is a algebraic function, and for integral of x to the power n, it is x to the power n plus 1 divided by n plus 1. Okay, so you increase that power by 1 and you divide by the same power. Let's look at a few examples. For example, let's say if you have x square, integral of x square, so you increase that power by 1 and divide by the same power, so x cube divided by 3. For example, if it is x to the power 10, that would be x to the power 11 divided by 11. Obviously you add the constant of integration c after all the integrals. Also remember that in this formula, x to the power n plus 1 divided by n plus 1, n plus 1 cannot be equal to 0. In other words, n cannot be equal to minus 1, because if n is equal to minus 1, the denominator will end up becoming 0 and this term will become not defined. So that means that when n is equal to minus 1, we cannot use this formula. And when n is minus 1, let's see what the formula is in that case. So when n is minus 1, so in other words, we have x to the power minus 1, which is nothing but 1 over x. Okay. Integral of 1 over x is ln x, natural log of mod of x. So remember that whenever n is equal to minus 1, in other words, integral of 1 over x is nothing but ln x. Now let's also look at one other special case. So for example, in algebraic functions itself, let's say instead of x to the power n, you have a linear term to the power n. What do I mean by that? Let's see. So if I have, let's say, ax plus b to the power n. So instead of x, let's say I have ax plus b, which is a linear term, and how to integrate that linear term. Whenever instead of x there is a linear term ax plus b, you can essentially apply the same formula, but just you have to do one thing extra. So integral of ax plus b to the power n is ax plus b to the power n plus 1 divide by n plus 1. So you can essentially apply the same formula. So you can increase the power by 1, divide by the same power, but remember that after integrating, you have to divide by the coefficient of x. So the coefficient of x here is a, so you have to divide by a after integrating. Okay, so you should write that a in the denominator. So that's the distinction, and that's the general rule that you can remember in any integral formula out there. Okay, if it's a linear term, instead of x, you have to just divide by the coefficient of x after integrating, and you can essentially apply the same formula, but just divide by the coefficient of x. Let's look at some examples. So for example, if let's say if we have 2x plus 5 to the power 10, let's say if you want to integrate that, you can essentially apply the same formula because it's a linear term. So you can write this as 2x plus 5 to the power 11 divide by 11, but you have to remember that you have to divide by the coefficient of x. Coefficient of x here is 2, so you have to divide by 2. So essentially that denominator will end up becoming 22. That's the only difference. So you can still apply the same formula, just divide by coefficient of x. I hope that made sense. Now let's look at exponential formulas of integrals. Exponential means that there is a constant and there is a variable in the power or in the exponent. So it's constant to the power variable. So example of this would be a to the power x, where a is a constant value to the power of a variable which is x. The integral of a to the power x is a to the power x divided by natural log of a. I hope that makes sense. We can again look at a few examples. Let's say if it was 2 to the power x. So integral of 2 to the power x is 2 to the power x divided by ln 2. We have a special case here. Let's say if it was e to the power x. So if it is e to the power x, the integral is e to the power x divided by natural log of e. We know that natural log of e is nothing but 1. So that would just give you e to the power x divided by 1, which is e to the power x. So that tells you that integral of e to the power x is nothing but just e to the power x. Even we know differentiation of e to the power x is also e to the power x. So that makes sense. All right, let's look at a special case. So for example, let's say if you have 2 to the power 3x plus 5. So instead of x, let's say I have a linear term. So you can still apply the same formula. You can still apply the same formula, but just you have to remember that you have to divide by the coefficient of x once you are done integrating. So integral of 2 to the power 3x plus 5 is 2 to the power 3x plus 5 divide by ln 2, but you have to divide by the coefficient of x. Coefficient of x here is 3, so you have to write that 3 in the denominator. That's the result. Okay, so remember, whenever there is a linear term, after integrating by applying the same formula, just divide by the coefficient of x. I hope that makes sense. All right, next category of functions we have is trigonometric integrals. In trigonometric integrals, we have 6 trigonometric functions. So we'll look at all of those first. So let's start with sine x. We know integral of sine x is minus cos x. Then we have cos x. Integral of cos x is nothing but sine x. Integral of tan x. Integral of tan x is nothing but ln mod sec x. Okay. Integral of cot x is ln mod sin x. Okay, so remember these integral formulas that we have over here. Then we have integral of sec x. Integral of sec x is nothing but ln mod sec x plus tan x. Integral of cosec x is nothing but ln mod cosec x minus cot x. Okay, I think we covered all the 6 trigonometric functions. We also have a couple of special ones, like we have integral of sec square x. Integral of sec square x is nothing but tan x. Why is that? Because we know differentiation of tan x is sec square x. The another special result that we have is integral of cosec square x. Integral of cosec square x is nothing but minus cot x. Again, why is that? Because we know differentiation of cot x is negative cosec square x. So integral of cosec square x is negative cot x. Because integral is antiderivative, it's essentially opposite of what differentiation is. After trigonometric, we have some special integral formulas that we would like to also memorize, which are very important. To start with, we'll start with integral of the function 1 over x square plus a square. Okay, so whenever you have a quadratic kind of a function in the denominator, so x square plus a square, the formula of this integral is 1 over a tan inverse of x over a. So remember this result. Okay, if it was 1 over x square minus a square, okay, if it was a negative in between this variable and a constant, the formula changes entirely. The formula becomes 1 over 2a ln of x minus a divided by x plus a. Okay, if it was 1 over a square minus x square, if the constant was first and then there was a variable and there was a subtraction, the formula is again 1 over 2a ln mod a plus x divided by a minus x. That's the result of the integral. Essentially what happens here is these two functions are really negatives of each other. Okay, so what happens here is even these two functions are then negatives of each other, and if you take a negative of this function, this, because of the property of the log, this becomes reciprocal. Essentially that's what happening over here. Okay, but that's the formula that we have. After that, the other special formulas that we have is 1 over square root. So if there is a square root and there is a quadratic, so if it is x square plus a square, the formula is ln mod x plus, you write the same function, square root of x square plus a square. If it was a negative in this, so if it was 1 over square root of x square minus a square, the formula would have been ln x plus, again the same thing, square root of x square minus a square. I hope it's making sense so far. You essentially have to memorize all these formulas in order to make your life easier to solve integrals. Okay, also let's say if the constant was first and then there was a variable, so if it was 1 over square root of a square minus x square, the formula would have been sine inverse of x over a. Okay, so remember, if it's constant first, constant square first, minus variable square inside of a square root, it's sine inverse of x over a. Okay, so after this we'll discuss three more formulas which are a little bit lengthier, but they are also equally important. So the next three formulas that we have are, what if instead of this 1 over square root of x square plus a square, we just had square root of x square plus a square? What would the formula turn out to be for integral? Instead of 1 over square root of x square minus a square, what if it was just square root of x square minus a square? And in the end, instead of this 1 over square root of a square minus x square, what if we just had square root of a square minus x square? They are a little bit lengthier, but I'll tell you a trick on remembering those formulas. So all three formulas that you see here start with x by 2. Okay, so all three will start with x by 2. So let me write x by 2 everywhere. Then you just write the same function. So x by 2 square root of x square plus a square. So same thing, square root of x square minus a square. And here square root of a square minus x square. Okay, the first formula and the last formula have plus. Just this one, which is x square minus a square, is negative. Okay, so remember that distinction. And then we have a square by 2 everywhere. So a square by 2. A square by 2. After that, what you have is, in that a square by 2, just multiply the formula of the reciprocal that you have for these. So for example, integral of reciprocal of this is nothing but ln x plus square root of x square plus a square. So over here you just write ln x plus square root of x square plus a square. Okay, that's the formula that I have for that integral. Okay, even here the reciprocal of this, the formula is ln x plus square root of x square minus a square. Okay, and here the reciprocal of this, the integral, is sine inverse of x by a. Okay, so those are the three special formulas where it is important that if you remember that, it would be amazing. It will make your life easier while solving integrals. I think we covered all the integral formulas that we need to solve most of the integral problems that exists out there. If you understand the concept that I'm teaching you, can I request you to like this video and subscribe to this channel? I do post math and calculus content every single day. If you don't want to miss the content, hit that subscribe button today. I'll see you tomorrow.